Do you kill them? A page like a large amount?
Oh wait, yeah, we're supposed to get a new paper, right?
Were also presented in Table 4.1 because Aristotle was one of the most influential philosophers of his time. Metricus' theory was eventually rejected.
All right, so we want to make a few notes from this table. We have Democritus. I would pick one of the four that you think is important, that you didn't know. Like, look at this table here on table 4.1 in your book on page 103. Just pick one of those ideas you did not know. And then the same for Aristotle. Pick one of the ideas you did not know about him. Aristotle thought that empty space could not exist, and he thought matter is made of earth, fire, air, and water. You can see I've got a couple examples up here. We were supposed to draw a line 1 centimeter up, place a dot, place it in 3 milliliters of water, and you can see some separation with the two chromatography papers on the right. The blue, the green, the yellow. So you can take some scissors and then cut right where the yellow is, and then you have the separation of the yellow from the blue. This is a method to do what? Raise your hand. Separate a mixture. Now there are other techniques you can do, like, what are the other techniques? There were 5 of them. Filtration, distillation, chromatography is the third one. Sublimation, and then one starts with a C. Crystallization. Usually you'll see salt and or sugar with crystallization. Now, we're not doing the filtration in the lab just because it's kind of messy. You get into salt and sand, and it's messy. Sand is very messy. So we didn't do that. This one, most of you have never done the chromatography. That's why we're doing it. And it's used more frequently, typically in the labs. Most of the time we purchase stuff that have already been distilled and filtered. They are pure from the company. And we'll do a lot of this chromatography in biology for DNA, separate genes and stuff like that. So the RF, you're going to create a little data table at the bottom of your lab write-up sheet. So you'll see this is the lab write-up sheet right here. You'll pick up one of these for your group. You have one per group, and at the bottom of the table, or the bottom of the lab report sheet, you're going to place a data table that looks like this. So we've got the dye, whatever color. If it's not labeled, just write what color you think it is. And then tomorrow we have some unknowns we're going to do. So we'll do this is the third day tomorrow. And then the DF value is from your pencil line to the solvent front line. So the solvent front, that is water, traveled a certain distance. That's the distance right here. You're supposed to mark that. And the DS is the pencil line to where the color goes. So from right here to the top of the color blue. I didn't mark the water line here. That was a mistake. I did that intentionally. So today, don't forget to mark the DF so that you can get an accurate reading for your RF value, because you have to have the DF to calculate the RF. Now on the back of this sheet, they have some examples for you on number 8. Now if you have an RF value of 0.91, did that travel farther than an RF value of 0.2? See if you can do some math real quick to see how your math comprehension is. If you have an RF value of 0.9, did it travel farther than an RF value of 0.2? Looking at this diagram.
Yes.
So if you have, someone said yes, that is true. So if you have two RF values, a 0.9 and a 0.1, the 0.1 really represents like 1 divided by 6. That is 1 centimeter divided by 6 centimeters. So if your DS is 1 centimeter, which would be right here, let's just say that was 1 centimeter, divided by 6 centimeters, you're going to get around 0.1. So that didn't travel very far. The lower number traveled a shorter distance. The 0.9 traveled a larger distance. 1 to 1, right? If you see 1 to 1, if this is 1 to 1, they're pretty much going to be at the same location. Does that make sense? So on your lab write-up sheet, they're just trying to show you that you can document data and then place it on a graph a lot easier if you have a ratio of the two. That's kind of what's going on. It's a good separation technique. Now on the back of the sheet that I gave you today, there's a little bit of homework, but there's also a writing assignment. So you probably had first period today and they talked to you about a digital backpack. Y'all familiar with that? Digital backpack? So we're going to just talk about that just a second. 10, 15, don't ignore that. I just modified this. I used some things again. The nice thing about using this again, we've had new Nobel winners, so you can choose a newer winner. But this is due on the October the 23rd, correction, 26th of 2018, which is a good month away. So I'm giving you some time to do this. I'm not trying to overwhelm you because the digital backpack is new this year. Everybody logged on to the digital backpack yet? Anybody not? Okay, so they're upset with you. This is Kaylin. She's like, this is her initiative to log on to that. So your technology class, if you have one, you want to do that. So basically what you're going to do, you're going to do a expository writing paper on a Nobel Prize winner. So you're going to pick a Nobel Prize winner and you're going to write about them. What I want you to examine? Well, I want you to examine some of the, I guess you would say, what's the word I'm looking for? It starts with the R. Struggles and or rejection. I want to know the rejections that the Nobel Prize winner faced, because rejections are kind of like failures. So you want to like figure out what they did and how they overcome their failures. That's what's going to make your expository writing paper really good. If you just talk about all the glorious stuff they did, people are like, okay, yeah, he's probably, had a family member that gave him a bunch of money and it was real easy for him, or her, or female Nobel Prize winners. You can choose one of those. One of my writers did. Elaine, she chose a female Nobel Prize winner. You can see her picture there. Also, I want you to do a little Photoshop. So in the Photoshop, you're going to kind of bring in your own little touch, like Elaine did. You can see here in the Photoshop, she made the picture her own. That's a very important thing to remember. If you ever go and you look at people who do writing, like published writing, they always have a picture of themselves. So you should have a picture of yourself in the article as well. It's another way of showcasing who you are. You always want to do that. And if you can then Photoshop yourself into the article, it shows you're kind of having fun as well. You're at the stage right now where you're not going to be able to go interview these people, but eventually you might be able to. So we're kind of playing a little bit of fiction here. And it's always kind of fun to mess around with Photoshop because you might need to do that in the future to make the picture your own. That's one of the benefits of using Photoshop. If you change it about 50%, is the picture, you can kind of claim it as your own artwork. And you don't have to pay somebody else royalty fees if you publish it. That's what I kind of look for. So people, if I take a picture and I publish it on the internet, they can come to me and say, Mr. Steinecker, which I will be publishing some of your papers. I'll choose some of them and I'll publish them on KentuckyTechnology.com. There's no advertising at my sites, primarily because of that. I don't want people coming to me and be like, that's my picture and that's my work and you're making money off it. You owe me money. Well, I don't owe you anything. I haven't made any money off of you. So yeah, I don't have any advertising on my sites because of that primarily, those copyright reasons. But if you do change the picture about 50%, you can declare it as your own artwork, which is what you want to get used to doing. Photoshop is a great tool to manipulate pictures. You'll do it anyway when you take your own pictures, just because you got to change the size, you might want to change the color. Apple's come out with a new iX that does all of this. It takes like 12 different pictures and it finds the best two, and so it's photoshopping to get the best picture.
Primary avenues to the truth. Curiosity sparks the interest of scholars, known as philosophers, who consider the many mysteries of life. As the speculated about the nature of matter, many of the philosophers formulated explanations based on their own life experiences.
Ideas that denied the existence of God. Incredibly, the influence of Aristotle was so great in the development of scientists, so primitive that his denial of the existence of atoms, but largely unchallenged for 2000.
So once again, I mean, he had a lot of good ideas on nature. He's considered to be the father of what? Biology. Father of biology, right? So who eventually proved Aristotle wrong? I'll give you 5 bullet points. You can tell me who eventually proved Aristotle wrong. No. Huh? Who eventually proved Aristotle wrong? I'll give you a hint. He's the father of chemistry. Yeah, Lavoisier. So Antonio Lavoisier, he was the one who proved Aristotle wrong when he determined that air was not a mixture. Correction, that air was not an element. So he determined air was a mixture. Lavoisier did that. So that's why Lavoisier is pretty significant. He proved Aristotle wrong. Now, was it 2,000 years? No. But he did set us on the track to look at Democritus and his thinking and figure out what was holding atoms together. There, Danny. Nice job. You got it above. You got some good color separation there.
Yeah.
The red and the blue. Really good. It's really good.
In the middle is red.
Yeah. Yeah, it looks really good. So I'll probably give it about another, 15 minutes and we'll be able to separate those. Good job.
In this setting, the power of the mind and intellectual thought were considered the primary avenue to the truth. Curiosity sparked the interest of scholars and thinkers known as the philosophers who considered the
4.1. While a number of Democritus' ideas do not agree with modern atomic theory, his belief in the existence of atoms was the main.
It's kind of been disproven as far as modern atomic theory is concerned. Can we take half of an atom? Yeah, you can split an atom today. It's called a nuclear bomb. Yeah, the nuclear bomb splits atoms. A nuclear power plant splits atoms. E equals mc squared, it's kind of what's going on there. When you do that, you produce a lot of heat. And if you can put it in a container, you create a bomb. So when you make a bomb, you have to have a fast reaction, and what else? A container it can break out of. If you've ever played around with firecrackers, if you see a dud, the gunpowder could not break out of the container. So if you drop bombs on people that the material inside can't break out of, they're just like duds. Are you familiar with that? A lot of that's happened in World War II. So it was tricky to come up with the nuclear bomb because you've got to create a container. You also have to create the material that it can break out of. So there's a lot of calculations that have to occur to get that right. Because if you drop, bombs on people that don't go off, they tend to laugh at you. They're not laughing when they go off, though, right? So Aristotle, he came up with the ether. Now on page 103, you're going to see a table there. Democritus. Write down one of the things you didn't know about him. They've got 4 bullet points. Just write down one in your notes that you didn't know. And it's the same with Aristotle. Like if you didn't know Aristotle came up with the idea that empty space cannot exist, write that down. He struggled a little bit. Who was the person who came up with the 4 elements of life? Was it Aristotle or starts with the H? Heraclitus. Remember we learned about him from the chemistry cartoon? Heraclitus. He was a Greek philosopher, and Aristotle came up with the 5th element. What was the 5th element called?
Ether.
Ether. And it has to do with what? Light and gravity. So you want to write that down. Fire, if you look at the picture in the book, fire doesn't have a white look to it. When we think about light, white light is composed of all of the colors on the spectrum. It's a very unique thing because it doesn't have its own specific set wavelength. Most colors on the spectrum have a defined wavelength associated with it. You can see that as the number right there, 7500.
That would be the wavelength.
White light does not have a set wavelength. It's got like a range. It does some things that are very unique. So Aristotle, he called ether, he defined it as white light and gravity. You're going to follow the lab instructions that you see right here. So step 1, you're going to follow these instructions, and this is the second part here. So if you have a specific question, ask.
Go whatever. Just go whatever.
You sit at the end. So I know. Alright. 3. Hold up. Mr. Seneca, these back. Chip second. 20. Put him on the left. Do we start like this?
I would. Whichever side is not going to turn away, so it can turn into the wood.
I was saying like, do we start behind it or like on?
I would probably start it on and just subtract that distance. But then again, you could probably just start it behind and you should be alright. Shouldn't turn that much. Just off a little bit. That's what I've seen so far.
Set, 2, go.
And then average. How do you average it?
So
Divide by 4.
they're doing their project.
Add them all together.
Scoring in the video.
Good afternoon, Eastern High School. Please listen up for your announcement. There's a bus change. Bus number 6.
What are we doing today?
To get on bus 1.
Put your stuff that we'll never need to know.
Yeah! Right, Mrs. Soniker, yeah!